Hello students. So today we'll continue from the quantification of what friction. Okay, so till now guys we have discussed we have discussed about what is friction. Okay, how do we define it, and after that we had discussed that what is the nature of friction. Okay, and then we discussed the cause of friction, and then we discussed guys what the types of friction. Now guys, till now we have just done the qualitative analysis of the friction. Now guys, we are going to talk about the quantification of the friction. So let me write down guys what the quantification quantification of the friction of the friction. So guys, here the things are going to be a little bit now more mathematical. Okay, so guys, see, it has been observed that the force that is acting between the contact of the two surfaces. Okay, let's say this is a block guys. Of course they are applying there is a normal forces that they are applying on each other. Okay, this normal force is one of the component of the contact force. So guys, it has been observed by experimental observations that guys, the friction force that will be available or that is going to act is directly proportional to what guys, normal force. Okay, it is going to be directly proportional to what guys, normal force. So guys, what we can say, if we create a equation with the equality guys, we have to put a some constant here and into what guys, n. Okay guys, remember this is what guys, this is an empirical relationship. Okay, this is what guys, a empirical relationship guys. This is not a law or something. This is just a guys a purely a experimental observation on the behalf of which we have deduced this relationship, that friction force is directly proportional to what guys, the normal force that is acting between the bodies or between the surfaces. Okay, so guys, there are two types of friction force as we have studied. One is what guys, static friction force. So guys, static friction force is what guys, it has a certain limit, that is what guys, FL. Okay, which is what, a limiting friction that will be equal to what guys, it will be given as mu s into what, n guys. It will be given as what guys, mu s into n, where guys mu s is known as guys what, static friction coefficient. Okay, is known as what, static friction coefficient. Okay, coefficient. Okay, and after that guys, for when the sliding starts, okay, when sliding happens, in that case there is a what guys, kinetic friction acts that we have discussed already, and that is guys given as what, mu k into the normal force. Mu k into what guys, the normal force, where guys mu k is known as kinetic friction coefficient. Okay, kinetic friction coefficient. Okay, so guys, here if you see, mu s and mu k are these two friction coefficients. So guys, if I make the graph of friction versus what, the force applied. Okay, so guys, if you see, let's say this is your friction, which is what, F static or F kinetic and guys, this is what, F applied. So if I take another color to just show this thing, so guys, let's see guys, up to guys what, a certain value, which is what, F limiting, which is what guys, mu s into n, the force will depend on the applied force. Okay, the force will depend on what guys, the applied force. If we apply guys what, less force, it will apply what, that much only force on the opposite side, so that the body will be what, stays in the equilibrium. Okay, and guys, after that what is going to happen, the friction falls from this, and guys then it attains what guys, some lower value, and this lower value guys, we know that that is what known as your Fk. Okay, that is known as what guys, Fk. That is known as guys what, Fk. I hope this you got it. Okay, so guys, this Fk is known as what, your kinetic friction coefficient. Now guys, I'll try to explain this dependence of what, the normal force on the of the friction. Okay, like why the friction force is dependent on what guys, the normal force. So let's try to understand this thing. Okay, I have given this idea earlier only during the start of what, the friction, but I'll just try to explain again guys, what the possible explanation. Okay, possible explanation of dependence on normal force of the friction. Okay guys, so guys, let's try to understand this also, that why it is so, that why the friction depends on the normal force, why the friction depends on the what is normal force. If you see, why it is not only the weight, why it is the friction force guys. If you see guys, if you are putting a body here, you know that guys, something this kind of a setup would be there, and let me choose this with the what guys, some other color, some guys, this kind of a thing would be there here. Okay, you know that guys, when the body is at, let's say in the, with respect to ground guys, with respect to ground, we are doing all the analysis guys. Okay, with respect to ground, if you see, if body is at what guys, having acceleration 0, in that case guys, you know that the weight of the body is going to measure the normal force guys, that how much normal force is going to act on the body. So in that case guys, we can say a more heavier body will have the more capacity of what, friction, which can resist the relative motion. Okay, are you getting my point or not? Okay, so guys, when the body is at rest, okay, with respect to the ground, we can say that the weight of the body is going to be the measure of what, the capacity of friction that is available. But guys, if you take a what, if you take a normal small body even guys, okay, and let's say guys, if I put this in a lift which is accelerating, okay, in the upward direction, if I am putting this guys what, in a lift, okay guys, which is what, which is accelerating, then guys, if you see from the ground or from the lift frame, wherever you see guys, what is going to happen, the normal force is going to what guys, is going to increase, that the body is applying on the surface, or the surface is applying what guys, on the body. Why? Because of the acceleration of the body. Okay, because of the acceleration of the body guys, the normal force is what, is gets increased, and because the normal force has been increased guys, it means what, the block is pushing the surface more comparative to guys what, its initial situation. So guys, because it is pushing the more, it means what guys, the possibility of the contact points, okay, or we can say the percentage of the what, the contact points will increase now, compared to what guys, compared to when the body is at what guys, at rest. Okay, so guys, now if you see, the percentage of what, the contact points will increase, because the pushing force that is applied by the body on the surface has been increased. So because of that guys, what is going to happen, the contact points will increase, the contact surface will increase, and due to that guys, what is going to happen, the normal force automatically increase. Why? Sorry, the friction force automatically increase guys. Why? Because the bond formation will take place now at a larger level, okay, compared to what guys, here. I hope you are getting my point, why the normal force is what, more fundamental quantity on which the friction would depend compared to what guys the weight of the body. I hope you understood why they have came with this idea instead of what guys the weight of the body. I hope this is settled. Okay, so guys, this was what the my try to explain that why this friction equation have come, why it has a dependence on what is the normal force acting on the body or the body that is applying on the surface. Okay, and these are the guys two formulas that you should remember. That is what guys, one is the static friction value, which is what guys for the maximum capacity of that is known as limiting friction, and that is equal to what guys given by mu s into n, and guys fk is equal to what guys, that is mu k into n, where mu k is what guys kinetic friction coefficient. Okay, now guys here I'll give you one remark. The remark is what guys, that in general guys this has been like this is a very common confusion that students has, that mu s or mu k will be what guys, it will be always less than 1 only, but guys this is not the case. It could be greater than 1 also, it could be greater than 1 also, than 1 also, and they can take any positive value from 0 to infinity. Okay, theoretically. Okay, 0 to infinity, of course not very high value generally like guys in reality exist. Okay, but of course yes, it can take theoretically any value from 0 to infinity. I hope this is settled guys. Okay, so now guys because we have understood the concept, now guys we can see some problems. So let's start with the very simple problem. I'll take now guys what few number of problems to understand the concept of what this this friction. Okay, so guys question number 1 for you. Okay guys, you can pause the video and you can try this problem, and then if you get it, that's okay. You try from your side. If you get it, that's good. If you don't get it, then just like come back to the video and then see the solution. Okay, so guys the very simple question I'm asking to you is, let's say guys there is a this is what, this is a block M, and guys remember one thing also, that mu s will be always greater than what guys, mu k, because guys if you know f limiting is always greater than guys what, fk, and guys f limiting is what guys, mu s into n is greater than guys what, mu k into n, and guys what cancel, so we can say mu s is always greater than guys what, mu k. Okay, so guys this you have to keep in mind. I forgot this thing. Now you just remember this thing guys. Okay, so this is also very very important. You have to keep this thing in mind. So now guys my question to you is that there is a block of mass m guys, let's take 1 kg. Okay, it is what guys, 1 kg, and here between the surfaces guys mu s is given 0.4, and guys mu k is given 0.2. Okay, mu k is given guys what, 0.2. so guys here there is a 3 Newton force is applied in this direction. My question to you is guys, find out the contact force, acting on the block from the surface, yes. Okay, so pause the video guys and you can try. Okay, so now guys I'll solve. Okay, I'll write the solution now guys, just see solution guys. So guys if you see, this is your what, the body guys, mass is given how much, 1 kg, okay, and guys the mu s is given how much, that is 0.4. it means guys what, the limiting friction guys, because the body is at rest, we can say that the normal force will be equal to what guys, mg, and the normal force is guys nothing but what, how much, 10 newton. Okay, normal force will be equal to what guys, 10 newton. So guys f limiting is available how much guys, 40 newton, because 0.4 into 10, that is how much guys, 40 newton. So guys available force is how much guys, this. Okay, sorry guys, 1 minute, I think there is some mistake that I did. This is what guys, 4 newton. Okay, that is what, 4 newton. Okay, now guys if you see here, in this case, if you see the force that is applied on the body is what guys, 3 newton. But guys if you see the capacity of the static friction with whom it can hold the possibility of motion is what guys, 4 newton. So how much force it will apply guys in this side, that is only the 3 newton. Why? Because it has to just stop the possibility of relative motion guys. So if you see guys, on the body there are two forces which are acting guys. One is 3 newton from the surface, and guys there is another force which is what guys, which is 10 newton in this direction. So guys of course these two resultant will be what guys, your net contact force. That will be what guys, your net contact force. So guys the net contact force R will be equal to what guys, under root of 10 square plus 3 ka square, because these both vectors are what guys, perpendicular to each other. So guys it is what, it is 109 under root newton. Okay, so guys this is what, this is your reaction force, or we can say the contact force acting on the body. I hope you understood this example guys. Okay, I hope you understood this example. Now guys let's take one more problem. Okay, let's take one more problem. Okay, is question number 2. Okay, question number 2 is what guys, suppose there is a body, okay, and guys let's say the mass is what, m. Okay, and guys here the friction coefficient are given mu s and what guys, mu k. These are the two friction coefficients are given guys. Okay, now the question asked to you is guys, what would be the range, what would be the range of contact force that can act, okay, that can act on the body, that can act on the body. Okay guys, I'll try to elaborate the question. Guys basically in this question they are asking that what could be the minimum contact force that you could have. Okay, that this much at least you are going to have if let's say guys the body is not accelerating or anything. Okay, it is resting on the ground, nothing else. Okay, so guys what could be the maximum contact force that you can generate. Okay, and the second case is what guys, how much the minimum how much minimum force you guys can generate. Okay, so it is basically guys, it's a HCB objective problem if I remember. Okay, it's a very good problem. So if you want to try guys, you can try this problem, otherwise I'll explain. Okay, so guys just see guys. So if guys f equal to what, if f equal to what guys, 0, if f equal to what guys, 0, in that case only guys if you see the minimum contact force you could have. Why? Because guys there would be no friction, because you are not applying any friction, any external force. So guys friction will not act, and in that case guys minimum to minimum what is going to happen guys, at least normal force will be what guys, acting on the body. So means guys what we can say, that R minimum will be what guys, at least mg. Okay, that is going to be the case. The minimum range is what guys, mg, that is going to act for sure on the body, even if you are not applying any force. Even if you are not applying any force, that much contact force is going to act for sure. Okay, that is the first thing. Now guys the second thing is, if you see the maximum friction force that can act on the body is how much, guys? You remember, that is what, guys? That is mu s into n. That is the maximum force that is possible, guys. And this will be how much, guys? This is your normal force. So guys, the maximum that you can create as a contact force, if you apply a force, guys, which is what, greater than FL, okay, in that case it, sorry guys, 1 minute, just let me do that. When F is equal to what, guys? F is equal to FL, then this condition will happen, okay, when the applied external force is just equal to what, guys? The limiting friction. In that case, what will happen, guys? The friction will be at its peak, okay, and normal force is always what, guys? It is going to be equal to mg if the body is not having any acceleration in the upward or downward direction. Then, guys, that would be the condition when the contact force will reach to its what, maximum. Contact force will what, reach to it what, guys? Maximum. So guys, what we can say, we can say that R maximum possible is what, guys? Is under root of n square plus what, guys? Mu s square into n square. So guys, I can take R max and I can take, guys, common, and that n is equal to what, mg, nothing else, 1 plus what, guys? Mu s square, okay. So guys, what we can say, that the reaction force will be, guys, less than or equal to what, mg under root of 1 plus mu s ka square, and guys, it will be always greater than or equal to what, guys? Mg, okay. This is what, guys? This is the range of what, the contact force that you could have, okay, the range of the contact force that you could have. I hope you understood this problem, okay. So this is a very simple problem, but guys, it has a lot of what, the technicalities in it, okay. So that's why I thought to take this problem here, okay. So I hope this is also, guys, settled. So let me go to the, guys, what, the next problem. So next problem, guys, is question number 3, okay, question number 3, guys. So guys, see, there is a wall, guys, okay, a vertical wall is there, and guys, there is a block, and guys, of course, there is a friction coefficient available between these two surfaces. Let's say, guys, mu is given to you what, 0.4 Newton, okay, guys. So sometimes, guys, in the problems you will see this kind of a situation where what, they will not give you mu s and mu k, okay, they will not give you separately the what, mu s and mu k, they will give you what, a single value, guys, they will give you what, a single value. So guys, we can treat this value only as what, our mu s also, and we will treat this value only what, guys, as our mu k also. So guys, if I have to calculate the limiting friction, I'll use this only, and guys, when I have to calculate the kinetic friction also, I have to use what, guys, this only, okay. So there are multiple problems you will see later, okay, where you will encounter this kind of a situation where mu will be given what, guys, only a single value. I hope you are getting my point, okay. So guys, suppose this is the situation, and now, guys, coming back to the problem, suppose this mass is given to you, guys, what, 2 kg, okay, mass is given to you, guys, what, 2 kg. So the question is, guys, how much minimum F I have to apply, how much minimum force I have to apply like this way, so that I can hold the body in like from the slipping downward, okay. So what should be the, guys, 1 minute, what should be the minimum F that we have to apply on the block, so that block does not slip downward, guys, okay. It's a very simple problem, guys, again, okay. I'm taking a bit simple problems for right now, guys. We will elevate the questions level gradually. So guys, tell me, so how we will encounter this problem? If you have, guys, any idea, you try from your side, and later guys I'll discuss. Okay, so guys let me solve this problem. Okay, so guys let's see. So guys, if you see, if I make the FBD of this body, okay, if I make the FBD of this body guys, so what is going to happen? If you see guys, the body is not moving in the horizontal direction guys. There is no movement happening in the horizontal direction guys. So because there is no horizontal movement guys, it means what? Net force on the body should be what? 0. Net force on the body should be what guys? 0. Okay, so guys, if you see here, if I am applying F in this direction guys, and there should be what guys? A normal force from this contact surface. So guys, of course, if body is in equilibrium, if I make the FBD of the body, okay, in the horizontal direction guys, so this will be what? F, and this will be what guys? Normal force. So guys, of course, F should be equal to what? Normal in every situation. Okay, F should be equal to what guys? Normal in every situation. That is the first thing. Second thing is guys, what? Because the body is not falling, it means what guys? Vertically also it is in equilibrium guys. Okay, vertically is also what guys? The body is in equilibrium. Okay, and if body is vertically in equilibrium, it means what guys? It means in the vertical direction also the net force should be what? 0. In the vertical direction also guys, the net force should be what? 0. So guys, if we see that what are the forces that is acting on the body, so one is what guys? One is nothing but what? The mg of the body. Okay, that is what? That is 20 Newton. Okay, that is what? 20 Newton. And guys, this side will be what? This side will be what? Your friction, which will what? Hold the body. So guys, this will be what? Mu into n, and that is how much guys? That is what? 0.4 into n, we can say 0.4 into, and maybe you can get in doubt guys that this is 0.4 Newton. So let me write down like this only, that this is what guys? Mu into n. Okay, and that is what guys? 20 Newton is what? Your mg. So guys, what we can say, we can write very simple equation that for equilibrium guys, the 20 Newton, which is equal to nothing but guys what? Your mg only, should be equal to what guys? Mu into n. I hope you understood. And guys, mu into n is nothing but what? I can replace the n from the f guys, so I can write mu into what? F minimum. So guys, from this we can solve the problem, that F minimum will be guys nothing but what? 20 divided by what? Mu value. Okay, so 20 divided by mu is how much guys? 0.4. So guys, it is what? 200 divided by 4, that is what guys? 50 Newton. Okay, it means guys, we have to apply what? Minimum 50 Newton, then only guys what? The body can be stopped from the slipping downward. Okay, from slipping what guys? Downward. I hope you understood this problem also. Okay, I hope you guys understood this problem also. Now guys, I'll take one last problem for today, and then we'll see some good problems in the next class. Okay, so I'll take one last problem guys. So 3 questions we have taken, one more problem I'm taking guys, question number 4. Okay, question number 4 guys. So guys, question number 4, if you see, so guys, the problem is like this way, that there is a body guys, there is a body having mass m equal to what guys? 2 kg, having a mass of what guys? M equal to what? 2 kg. And guys, here mu is given to you 0.2. okay guys, it has been said that this body has been given a velocity v0, that is guys 4 meter per second. That is what guys? 4 meter per second. Question is asked like this way, find out how much distance the body will travel before it get stopped. Okay guys, so this is the question. It's again guys a very simple question. Okay, so you please try. Okay, and now I'll solve. Okay, I will solve. So guys, if you see, how do we solve this problem? Very simple guys. If you see on this body, what are the forces which are acting guys? One is what? Mg, and one is what guys? Normal force. But in the vertical direction there is no motion is happening guys. It means what? The mg is equal to what? Normal force. I hope this is settled. But guys, body is, because sliding is happening between the what? Between the ground surface and between the blocks guys, it means what? There is a kinetic friction is going to act on the body. The kinetic friction is going to guys what act on the body. So guys, if the kinetic friction is going to act on the body, so guys it means I can write that on this body, if you see, there is a friction that is going to act guys, that is what mu into n in this direction. And guys, if you see, the initial velocity of the system is given how much, 4 meter per second guys. Because of this friction force, there is a retardation going to happen in the body. Okay, so guys, if I calculate the acceleration, basically the negative acceleration that is happening on the body will be how much guys, that is mu mg guys, because normal force is equal to what, mg divided by what guys, m. So m guys cancel, so it is what guys, mu g. So guys, the retardation will be how much, mu into g. So guys, what we can write, we can write that it is asking after how much distance traveled the body will stop. So guys, we can write v square is equal to what, u square plus 2as. Why I can write this guys, why, because if you see this value, this is what guys, this is a constant, because mu is constant guys and g is also constant. So guys, you are having a constant retardation, and in the constant acceleration or deceleration guys, we can apply this equation, you know that. Okay, so guys, in that case, if you see, this will become what, the final velocity will become what guys, 0. Initial is given how much, 4. So guys, 4 is what, 16. And guys, because retardation is happening, so minus 2 guys, a is how much, a you can calculate from here, that is what, 0.2 into 10, that is how much guys, 2. So guys, this is what, 2 into what, s. So guys, if you see, this is minus 16 is equal to what, minus 4s, minus minus cancel. So guys, s is equal to what, 4 meter. Okay, s is equal to what guys, 4 meter. So guys, I hope you got this question also. So guys, we have just seen today that how do we quantify the friction force, and guys, we have seen some very basic problems on what, on this quantification of what guys, friction, and the idea of what guys, friction. Okay, tomorrow we will see few more concepts, and we will see some few little bit more difficult problems compared to the today's problem. Okay, so thank you guys for today. Okay.